Is it now visible to you?
Yes, sir.
Okay. So we will discuss about what we have discussed in the last class regarding the conditional probability Markov chain. I will give you some of the examples so that you will be more clarity rather than the theoretical part. Okay. So let us say that a bowel, there was a box or bowel where you have five red balls and seven white balls. Okay. Now, what is the probability of getting a white and a red ball at a two draws made without replacement? Very simple. What is the probability of getting a white and a red ball at two draws made without replacement? Okay, so now you can see two draws. That means it is a condition. One draw after another draw, or maybe simultaneously you draw. Now, what it, again it is telling without replacement. That means first you draw a ball, then you should not replace that ball to again to the bowl or the box and draw it. Okay, so with replacement and without replacement, there are two conditions, or maybe there are two separate scenario. Okay, so that is actually conditional probability. Okay, now a a box contains five red balls and seven white balls. So altogether, how many balls are here? 12. Yes or no? 12
Yes, sir.
balls. Now, in that 12 balls, that five are red and seven are white. Okay. Uh, let I'm going to take the answer. Let A1, A2, B1, and B2. Okay, there are four events I am taking. Okay, four events that the first ball drawn is red, the first ball drawn is white, the second ball drawn is red, and the second ball drawn is white. Okay, so the first ball drawn is red, the first ball drawn is white, the second ball drawn is red, the second ball drawn is white. Okay, so this is the four event. First ball, let us write F red, F white, and second ball S red and second white. Okay, now what we are actually interested calculating the probability of the events, that you look the event, probability of getting white and a red ball. So probability of getting white and a red ball, so what does it mean? Probability of getting white and red ball, so this may be the combination. Okay, what is that? A2 intersection B1, or there may be a combination of red and white. Okay, yes or no? Where the first ball drawn is red and the second ball drawn is, so it is not, it never been told that the first ball will be white and the second ball will be the red. Are you getting my point? So that is actually the difference, the condition. It says that find the probability of getting a white and a red ball. So either you get red and white or you get white and red, both are favorable condition to you. Okay, so this is one favorable condition. Another one will be favorable condition is A1 intersection B2. Yes or no? Are you getting my point? This is my red and this is my white. So this two will be a combination and this two will be a combination. So that is favorable to you. Okay. Now the required probability, if we write the required probability will be what? This is one condition and another condition is union of this one. Okay, so this is the probability actually you are interested. So what is that? If you remember the laws we have discussed in the previous class, probability of A1 union A2 is probability of A1 plus probability of A2. So that we can write probability of A1 intersection B2 plus probability of A2 intersection B1. Now, because they are two mutually exclusive events. Now, probability of A1 into probability of B2 plus probability of A2 into probability of B1. Okay. So because why how I have written these two? Because they are all mutually exclusive events. If it is with replacement, then we will have a separate answer. So what is the probability of A1? What is A1? If you look to the previous page, what is A1? Probability of finding red. So what is the probability of finding red? How many reds are there? 5.
Fine.
So 5 by 12. What is the probability of getting white? 7 by 12. So we will go with that way. Okay. So probability of getting a white is 5 by 12. Now next is probability of B2. What is B2? What is B2? B2 we have taken white. White made without replacement. तो क्या होगा? What will be your answer? One ball you have already picked up. So how many balls are there? 11 balls. What? How many are white? 7 are white. So this is the event for probability of B2. Now plus probability of A2. What is A2? Getting the first one is red. So what is the red? Red probability? That is uh, sorry.
4, sir.
Uh, what we have taken A2. A2 is white. No, this is separate, na. This is first. This is for one favorable. Four will be not there, na. So already this part is over. Then when you are going for A2 event, you look the A2 event. What is that A2 event? A2 event first ball is white. So first ball is white. So what will be the total number of balls will be 12. How many number of balls are white? 7. Then second ball is red. So how many number of balls are there? Red. 5. How many number of balls are there without replacement? 11. You got my point. A1 I am writing here so that we should not uh, again switch and switch. There are 4 events. What is A1? A1 is the first ball drawn is red. First ball red. Then first ball white. Second ball red. Second ball white. Now I am interested to calculate probability of A1. That means red ball from the bag of 12. 7 white and 5 red. From the bag of 12. So that is total number of ball is 12. How many red balls are there? 5 red balls. So that is the probability. Favorable number of cases by total number of cases. Then what is B2? B2 is the कहाँ गया B2? B2 is this. Okay, this one is B2. Second ball is white. So second ball is white without replacement. So there are total 11 number of balls. And how many number of are white? 7. There are favorable cases for 7. 7 by 11. Then that is over. Next one is A2. What is A2? You see here. That first ball is white. So total number of balls are 12 and 7. So this is one case. This is one case. So you should not mix that. This is 4. Okay, 4 and something. So 7 by 12 into 5 by 11. Is it clear? So whatever the answer will come, you simplify. I have did it. So this will be the answer for this question. Okay. So let me ask you one more. Okay. So that you will be clear. We'll do more and more questions here. Now two cards are okay. Suppose it is with replacement, then I will go to. If it is with replacement, then what will be your answer with replacement? Very simple. This will be 5 by 12. Again, it will be 7 by 12. Plus, this is 7 by 12 and this is 5 by 12. Okay. Denominator will be 12 because you are replacing this ball to the box. So, ultimately, there are always 12 balls. Okay, are you getting my point? So this will be your
Yes, sir.
answer. Now next question, we will go that two cards are drawn with replacement from a full deck of 52 cards. Now what is the probability? Let me write it. Two cards are drawn with replacement from a full deck of 52 cards. Now what is the probability? What is the probability? Both cards are spades. Both cards are spades, and that are either two hearts or two diamonds. Second one is either two hearts or two diamonds. Okay. So let us see. What is the probability? Both cards are spades. So let me answer. Very simple. Okay. So how many number of cards are there?
52, sir.
52. How many number of spades cards? There are four type of cards. If you have remember, one is spade type that looks like this, and another one is diamond, and another one is heart. Spade, diamond, heart, and one more was there. What is that? That club. Okay, so this is actually club. This one is actually spade. This is spade. This is club. Okay. So how many number of spades cards are there?
13.
13, 13, 13, and 13. So there are 13 number of cards which is spade. Okay. So now look at this. Both cards are spades. So both cards are spades means one is 13 by 52. Next event will be again 13 by 52. Yes or no? You are simultaneously drawing two cards. One card will be spade, the other card will be spade. So this is your, if it is without replacement, then one will be 13 by 52. The second one will be 12 by 51, because one card of spade you have already taken. Are you getting my point or not? Okay. So
Yes, sir.
probability of A and B will be 13 by 52 into 13 by 52, that is 1 by 16. In this case, the answer will be, that is 1 by 4, 1 by 4. So this is 1 by 16 will be answer. Now look, go to the next event. What is the next probability? Either two hearts or two diamonds. So if it is two hearts or two diamond, let A1 denote the event of drawing two hearts. So I am taking this as two hearts, A1, and or na, either or. So this is two diamonds. Let us say this is my A2. So what I am interested, probability of A1 or A2. Or means what? Union or intersection. And is intersection or is union. है कि नहीं? So probability of A1
Yes, sir.
union A2. So probability of A1 union A2 means what? It is probability of A1 plus probability of A2. Okay. So what is probability of A1? Probability of A1 getting an event drawing two hearts. तो कितना hearts है? 13. So similarly this will come also 13 by 52 and 13 by 52. So how much it is? 1 by 16. In this case 1 by 16. Are you follow me or not? Two hearts.
Yes,
Two
sir.
hearts. How many number of hearts are there? 13. So 1 by 1. So 13 by 52 into 13 by 52, 1 by 16. Similarly, two diamonds. Two diamonds A2. That is also 1 by 16. So 1 by 16 plus 1 by 16. How much it is? 1 by 8. Okay. Clear? Now I will slightly change the question and I will ask you again that same question without replacement. I already told you, if I go with the without replacement, the answer will be 13 by 52 and 12 by 51.
And
So what will be the
51.
answer? Hmm. So the answer will be 1 by 7. Okay. So that is probability of A and B. Okay. And what is that? Probability of A into probability of B condition A. That what is that? What is my B event? The next card will be a spade card, whereas the first card will already having a spade. Okay. So probability of the next card is a spade card or heart card, where this card is already of spade. So in that case, this formula, this conditional probability, what we have discussed in the previous Sunday class. This is the conditional probability, probability of A intersection B, where they are not independent, they are dependent. A intersection B, uh, let me write it perfectly. That probability of A into probability of B condition A. Okay. So this is probability of A is 13 by 52 and this is your 12 by 51. Simple. Okay. Now let me give some tricky questions to you. Okay. So in a family, suppose in your family you have 6 children, assuming the probability of having a male child to be 1 by 2. Okay. And find the probability that all the children will be of the same sex. Okay. So you in your family you have 6 children. Out of these 6 children, one is male. Okay. So what is the chance of being male? Chance of being, because your sample is now female and male, so what is the probability of getting male? 1 by 2. So that I have written. Okay. Now find the probability that all the children will be of the same gender or same sex. Okay. So if how many children are there? 6 children. What is the probability of getting first one is male? That is 1 by 2. Probability of getting A1. So how many number of events you are? 6 events. A1, A2, A3, A4, A5 and A6. Just a minute. Somebody has joined. So why you are so late? Anyhow. So you this is just like a entering a movie hall where you will have no clue to understand the things. Okay. Suppose you are not belongs to a language and you have entered to that film hall to watch that movie. If you are at the beginning, then you might follow what we are discussing. If you are at middle of the class or maybe towards the end of the class, then you cannot follow. It is just like a Telugu lecture if you are not belongs to Telugu or Tamil film. Okay. Anyhow, find the probability that all the children will be at the same sex. So will be A1, A2, A3, A4, A5, and A6. So this is 1 by 2, 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 and 1 by 2. So how many will be there? 1 by 2 to the power 6. Answer. Is it clear? Every uh, those who are present? Yes or
Sir,
no?
repeat once, sir.
Huh. So you have 6 children in your family. I am interested to find out to know the gender of the 6 children. So what I am interested to find out the probability of all the gender of the children having the same gender. Okay. So if they are having the same gender, so probability of either they all are male or they all are female. So what is the probability of getting a male? So getting the male is having the probability of 1 by 2 because your favorable. What is probability? In the last week, Sunday, we have discussed about that this is number of events by favorable number of cases, measure of an uncertainty. So what are the number of cases here? Male and female, either it is male or it is female. So there are total two samples. What is your favorable? Either male, male means it is 1 by 2, or maybe it is female, that is also 1 by 2 because there are only two samples here. So the first one will be a male, second one will be a male, third one will be a male, like this, six events. So 1 by 2, 1 by 2, 1 by 2, 1 by 2, 1 by 2. How many times? 1 by 2 to the power 6. That is your answer. Now it is clear?
Yes, sir.
Okay. So now let me go with some other kind of problem which does not have uh, mm, uh, okay. Now what is the probability that each of the players okay, let me write it. Okay. Okay. In a company, some complex problem. In a company, there are actually 8 junior officers. Let us say in your IGNOU office, there are 8 junior officers and 4 senior officers, and 3 persons are selected randoms. Okay, so there are 8 junior, 4 senior. Okay, so if they are in your office, okay, or you can say 8 male persons, 4 female persons, number of variety questions you can make it with this. Okay, in your house. Now I am picked 3 persons randomly. Okay, 3 persons at random to form a committee. To form a committee. Okay. So what is the probability? There will be 2 junior officer and 1 senior officer. There, what is the probability? What is the probability? There will be 2 junior and 1 senior. Okay. Similarly, the family problem also. There are 8 male persons and 4 female persons. 3 persons I will select at random. What is the probability? There will be 2 male and 1 female. Okay. Same question can be written in another way. So now you have to prepare a committee where in this question that the committee of 3 people where there will be 2 junior and 1 senior. So how many ways it can be made? So first you have to find out this, then we will go to the favorable cases and total number of cases. So out of 8 juniors, 2 officers can be selected. In how many ways? It is C 8 2, or how you are writing, I don't know. Maybe some people are writing in this way and some people are writing in this way, 8C2 wage. Okay, so whatever the notation you are using, it doesn't matter, it is a combination. You are choosing 2 people out of 8 people, 2 juniors out of 8 juniors. Am I clear?
Yes,
You are selecting 2 male out of 8 male. Okay, clear? So how many ways? Suppose you are selecting John and Mary, or John and say Hari. So both Hari and John and Hari are same. Okay, so in that case, you will have two combination, not permutation. Okay, so what is that formula? 8 factorial by 2 factorial into 8 minus 2 factorial. That is 6 factorial. Am I clear? 8 factorial by 2 factorial into 6 factorial. Yes or no?
yes, sir.
8C2. Now, next, how many senior officer you will select? You will select 4C1 out of
C1.
4C1. So, so this is 4 factorial by 2, sorry, by 1 factorial into 3 factorial. Okay. Now, total how many people you are selecting? 12C3. 3 peoples out of 12. So what will be the probability? So this will be divided by this. That is 12 factorial into, sorry, 12 factorial in, by 3 factorial into 12 minus 3, 9 factorial. So this is your answer. It is clear or not?
Yes, sir.
Okay. Now let me go with another question. Find the probability that in a bridge game, at least one of the players will get a complete suit of cards. Bridge game, you have ever played?
No, sir.
Okay, so that is, if you have a complete set of cards, then you will have to win. Otherwise, you will not win. Set of cards means that is 13. Okay, each set is having 13 cards. Just right now we have discussed four type of cards
Yes,
are
sir.
there:
Yes.
club,
Yes.
spade, heart, and
Diamond.
diamond. So there are 13 cards of one set. Okay, so if it is there, then you have to find the probability in a bridge game. At least one of the players will get a complete suit of cards. Okay, so in a bridge game there are four players. Okay, so one player, two player, three player, four. Out of four players, at least one player is having a suit of cards. So at least one means maybe two players are having the set of cards, maybe three players having the one set of cards, maybe four players having the set of cards. Okay. So in that case, how will you be able to find out this question? Okay. So first you have to find out for all, then you minus it. Then you will get the at least. Okay. So exactly one player, then in that case you have to pick up 13 cards out of that. Okay, so let me do it. That means we are interested to find out the probability of A1 union A2 union A3 union A4. That means A1 is the player which gets a complete suit of cards. So maybe one player, maybe two player, maybe three player, maybe four player. So that is my all player. Okay, I can write it this with is equal to summation of I is equal to 1 to 4 probability of AI. Yes or no? Okay.
Yes, sir.
Now this will be minus of sum of probability of AI intersection AJ. That means I am not interested of having intersection of two. I am interested only at least one player. Okay, so this will be deducted when I less than j. So that means A1 intersection A2 when you have common players having bridge. So I am not interested for that common players having bridge. I am exclusively interested for one player. Okay. So similarly, you might have three players, common players. That means A1 intersection A2 intersection A3, maybe A1 intersection A3, maybe A4. So you have to subtract that also. Three events: AI intersection AJ intersection K. And again you have to subtract all players. That is AI, AJ, AK, and AP, because there are four players. Okay, are you getting my point or not? Or you can directly write 1, 2, 3, 4, because you are writing for all players here. Here you can have variables because you are permuting here. But 1, 2, 3, 4, the same thing will come. Okay. So actually this way, if you go, it is difficult to find out. So it is better to find out in a other way and subtract this to get it the answer. Okay. So you try this. So probability of AI will be what? 4C1 divided by 52C13. Okay, 13 cards out of 52 and one player out of four player will get. So this is your probability. For AI, similarly for A2, A3, A4, A5, A3, A4. So you have to sum it. That means summation of this with respect to 4. Okay. So you try this, you will get it. If I solve, then it will consume time. I hope you have already know this. Okay. Now let me go with another example to give you more clarity. Let us we calculate one example. This is clear, or I should solve with this?
No, sir, it's okay.
Okay. Okay. So let us go that another one. Suppose a person writes n letters. Okay. So okay. If, before I proceed for that, so oh, one more person has joined, but maybe 10 to 15 minutes after we will complete the class. Okay. So your class is 10 o'clock, not 11 o'clock. Okay. Mamta Mandal. So you are too late, already 50 minutes over. Anyhow, so before I start with this example, let me say about something queuing theory. Anybody who knows this? Hmm. Queuing theory? Because if I continue, then these latecomers will be in trouble. Queuing theory? What is that actually? Queuing theory. Anywhere in this world, if you go, we tackle the problems through this. What is that? Suppose recently you have taking your COVID vaccines. So okay, so when you go for taking COVID vaccines, what the approach you have followed? First come, first out. First come, first out, or first serve. FCFS, or sometimes we called it as first in, first out. FIFO. Okay. FCFS or FIFO. What does that actually it means? Okay. See, when you go to the vaccine center, you stand in a queue. You stand in a queue. When you are going to railway reservation ticket, you stand in a queue. When you are going for bank for transaction, you stand in a queue. If you are interested to take some kind of work at your IGNOU center, you stand in a queue. That means those persons who are coming fast will be solved fast. Okay, that is the way we actually solve this. So many of the problems in this world actually solved through queuing process. So that is called queuing theory. Okay, so how we'll do that, and actually how it helps in computer point of view or in with mathematics point of view. Look at this: 2 plus 3 multiplied by 5. What will be the answer?
25.
25. Why it is not 17? Hmm.
No, sir, 17. What?
No, maybe 25 will come answer because you have executed in this way. So you have added 2 plus 3, that is 5. 5 into 5, that is 25. It is also correct. You argue in that way. I will say that 5 into 3, 15 plus 12, 17. I have goes in this way. That is from right to left. You have gone from left to right. No, I have not given you the well defined way or correct way to execute. So both of you are correct. You are also correct, I am also correct. Now the system cannot to go with this. That means there are two answers as you discussed in the previous class, then we cannot proceed. Okay, so we must have some theory that either I should execute from left to right, or I said I should execute from right to left. You might have remember we have rules of bracket of division, multiplication, and addition and subtraction. Okay, that Badmas rule. Okay, so division will be executed then multiplication, then addition, then subtraction. So in that theory, I will multiply first, then this will be added to with this. Okay, now the same thing you have to do with respect to a rule or a theory. So in that case, either I should go with a queue. What is that? In an array in a computer memory, I will enter this, then I will follow this side either, or maybe from this side I will first take 2, then there is a operator and this is a operand. So the operand will come, then 2 plus 3 will be added, the result will again come to this array, then 5, then 5 will now come, then next is multiplication operator, 5 and 5 will be 25. So I will get 25, not 17. So I must have to write. So how will do that? That is known as either one way from right to left or from left to right. That is called queuing process. Queue process. Okay. Most of the network operator, suppose your computer is connected you in your office or in your IGNOU center, there are 60 computers. Okay. All are interconnected. Maybe say 10 computers, they are interconnected, and you have only one printer. Okay, and everybody is doing their work, and finally the report is generated at the printer. Okay, so person 1 is interested to print or generating the report, person 2 is interested to generating the report, person 3 is interested to generating the report. So how actually the system will take care? So system is having a queuing process. So when the person 1 requested, so the person 1 is requested with 10 5 a.m. Then person 2 is requested at 10:05 2 second, 2 microsecond. Then this person has to be solved fast than this person. That is known as a theory or queuing theory. Everybody clear? Everybody clear or not?
Yes,
So
sir.
when you have multiple channels or multiple operations, and in your statistics or in your probability, you have to go through with a theorem that is popularly known as queuing theory or queuing process. Okay, so what is that process? That this process is actually required for execution or the system performance of a CPU or any kind of work. Okay, when you have multiple job and every job is sharing with a single source, then the job from the queue will be selected for serve. That means fast come fast service. What I told you, if you have come to the teller or the counter fast, then you will be served fast. Okay, so there are actually two type of queuing process: open queuing and close queuing. So what is that open queuing and close queuing? Okay, this is actually theoretical part, and in case of the Markov chain we have already discussed that one by one, after the, if there are multiple chain of events, then how we will actually tackle this. Okay, one event is coming, then the next event is coming. So when the next event is coming, that means this is the event number 1 has to be executed first, then the event number 2. Okay, so you have to do some kind of topological sorting there. The last class I told you that regarding the a company which is having multiple operations and you are having a assemble unit. So if one part has not, in case of the foreign countries, they do not, their laws does not allow to do strike. Okay, so strike means, so you should not go to the office and you will say that I am in a strike, I will not do the work. Okay, so the law does not permit to them. So what they do, suppose you are in a shoe manufacturing company, they only go to the office and produce left side of the shoe. That means the company cannot sell. They are actually present in the company, but the company could not make profit due to this strike. So their protest and our protest are different. Okay, so So in that case, that means when you have a car company, when you have a any kind of manufacturing company, you have separate unit. All units are actually interlinked, and these are actually processed in a queue way, so that one after another will come and we will assemble the product at the last to put it in the market. Are you getting my point? So let me go with an example so it will be more clear. Okay. uh, then I will again go back few of the examples of conditional probability what we have discussed since the morning. And let us say a repair facility shared by a large number of machines has two sequential stations. Okay, it is a repair facility. That means you have one station, let us say one fire station. Okay, so in your city, one fire station was that. In your fire station, you are receiving the calls from multiple buildings that you have a fire incident. So how the fire station will work? So suppose this is building number one, building number two, building number three, and you have a fire station here. So you received a call from building number two, then you received the call from building number one, then you received the call from building number three. So how you will sort to them? This is the order. This is actually queuing theory. You sort them, then you sort, then you sort. This is first, this is two, this is three. Okay. So if you are going for finding the probability of their survival or their chances of survival, because you are in a fire, so what is the probability of the person at the building 3 will survive, or what is the probability of a person having building 1 will survive? So if you are solved last, then what your probability will be less. If you have solved fast, your probability will be more. That means you are giving more weightage to the fast solve. Are you getting my point? So you give some weightage to that, and then you solved with that way. Okay, that means this weightage will be multiplied with your probability. So let me tell you with this example. I hope you understood from this discussion. Yes or no?
Yes, sir.
So, because you are in a critical condition, and if your call has been received by the fire station or service station fast, then your chances of winning or your chances of survival or your chances of diminishing the fire at that building will be more compared to this. Okay, but this may be the drawback of the queuing process. Then we'll do some priority means if it is your chief minister building, then you should even if you have requested fast, but this will be executed fast. Okay, so that priority queue concept will come, which may be violate the fast come fast serve process. Okay, anyhow, let me say the theory, then we will have that discussion. Okay, so let me write this with an example. A repair facility shared by a large number of machines has two sequential stations with respective rates 1 per hour and 2 per hour. Okay, you have a repair facility having two sequential stations. This is your repair facility having two sequential stations. Okay, sequential means one after another. पहले जो भी जॉब आएगा one will be executed here, then it will be executed here. Okay, two sequential stations with respective rates of 1 per hour and 2 per hour. Okay, this is 1 per hour and this is 2 per hour. The cumulative failure rate of all the machines is 0.05. 0.5 let us take, not go for fraction, more fraction. So 0.5 per hour. Assuming that the system behavior may be approximated by the two-stage tandem queue, determine the average repair uh, given time. Okay, so you determine the average repair queuing time. Okay, so let me write this question. A repair facility shared by a large number of machines and has two sequential stations with respective rates of 1 per hour and 2 per hour. Okay, so the failure rate is 0.5 and what will be the queuing? Okay, so to answer this question, we have to define the failure rate for each machine. Okay, so this is first zero point 0.5, and you have two machines, say mu 01 and mu 2, that is 1 hour and 2 hour, and we have let us say row 0, probability of 0 of the this, and probability of 1 half of this. Okay, that is 0.25. Okay, so the average length of the queuing station will be that formula, expectation of ni will be probability of I by 1 minus pi. Okay, you go through your book notes. Okay, now we have to calculate the uh, queuing formula for the event here n0 and the event for n1. Okay, so for n0, definitely the machine is purely available to you, though, so you will be solved immediately, and that is one certain event. Now probability of n1, let us take this is 1 by 3 because total hour is 3, 1 hour and 2 hours, so you have 1 by 3, so that may be the waiting time for this. Okay, so if you use this formula, then you will have that calculation of this. Okay, let me complete this with writing. I don't know which notation your material will be. I am writing with this notation, and the will be this n0, the required waiting time. Okay, n0 by the failure chance. Okay, that is 0.5. So n0 will be 1 and the failure chance will be 0.5. So this is 5 by 10. So this is 10 by 5. So this is 2. Okay, and the next waiting time for this will be similarly this one with your lambda. This is 1 by 3 and 0.5. So this is 1 by 3 into 10 by 5. So this is 2. So this is 2 by 3. Okay, so this is 2 by 3 hour. This is 2 hour. Okay, obviously fast machine is executing, that is 1 hour, next machine is 2 hour. So what will be the next hour for this waiting time? Queuing theory 2, and this will be 2 by 3 hour because you have partially executed the job. Okay, and in an average for that station, if you go, then you will get it that a total hour of waiting will be this r0 plus r1. So this is 2 by 2 by 3, so this is 8 by 3 hours. Okay, and if you go with the service with respect to the formula, then this will be the reverse one. Okay, 8 by 3 and 3 by 8. Okay, the reverse will be 3 by 8 because ultimately you will get with 1. Okay, so we go through the book notes. I hope you have understood, and in the afternoon class we will discuss more little bit problems of probability, conditional, and some queuing theory problems. Okay, then we will stop the class. So if you have any doubt, you can ask me, otherwise I'll stop the class.
Okay, sir, no doubt, sir.
Okay.